A gravel boat ramp sits at the edge of King Sound near Derby, facing grey silt, mangled mangrove roots, and a rusted steel pontoon resting flat on bare mud. Twice every day, this single gulf drains 2 million megalitres of seawater off the continental shelf and pulls it back out into the Indian Ocean. Hydrographers mapped these channels for over a century as routine coastal navigation hazards, missing that an entire submerged human landscape lay intact beneath the surge. How much of the continent's real history sits permanently drowned beneath the waterline? Later, we will examine a drowned valley in Bass Strait, where ancient forest stumps stand 60 metres below the surface, and at number 1, a limestone shelf off the Pilbara coast, where stone artifacts lie undisturbed on a seafloor dry 12,000 years ago. For over a century, official charts treated the Australian coastline as a fixed boundary, assuming the ocean edge seen today was where terrestrial activity always stopped. That assumption was entirely reasonable when early Admiralty hydrographic surveys relied on surface lead lines and visual sightings, leaving everything below the surf line invisible. Number 30. At King Sound in Western Australia, the spring tide rises and falls by 11.8 metres, the largest tidal range in the southern hemisphere. When the water recedes, it exposes hundreds of square kilometres of intertidal mudflats stretching across the mouth of the Fitzroy River. This churned silt harbours millions of tiny benthic amphipods, driving an ecological engine that feeds over 20,000 migratory shorebirds every spring. What appears to be an empty mud basin is actually one of the most productive feeding grounds on the Western Australian coast. Number 29. Out in the Kimberley region, Montgomery Reef covers 300 square kilometres of coral platform in Yampi Sound. As the 10-metre tide drops, the surrounding ocean falls faster than the water trapped atop the reef flat. Seawater cascades off the exposed structure in hundreds of torrents, creating massive roaring waterfalls in the middle of open ocean. Early navigators logged the feature as a navigational hazard, unaware that the dynamic head of water was created entirely by tidal drainage off a perched carbonate platform. Number 28. In Talbot Bay, tidal currents force massive volumes of seawater through two narrow gaps in the Maclarty Range, creating Tawanjara, known as the horizontal falls. The seaward gap spans 20 metres, while the inner gap narrows to just 10 metres. During peak spring tides, water piles up faster on one side of the ridge than the gaps can discharge, producing a 4-metre vertical height difference between the basins and driving currents exceeding 20 knots. The phenomenon is not a waterfall from a cliff, but a reversible hydraulic bottleneck created by folded sandstone ridges. Number 27. In the snowy mountains of New South Wales, Lake Yucumbene covers the former township of Old Adaminaby, submerged in 1957 during the construction of the Snowy Mountains scheme. When severe drought reduced the reservoir capacity below 10% in 2007, the drowned town re-emerged from the water. Visitors walked along intact bitumen streets, concrete house foundations, and the remains of the 1906 stone church, revealing a settlement preserved under silt for half a century. Number 26. In northeastern Victoria, the original town of Tallangatta was relocated 8 kilometres west in 1956 to allow the State Rivers and Water Supply Commission to expand the Hume Reservoir on the Murray River. Known as the town that moved, Old Tallangatta was inundated under metres of water. During dry periods, low water levels exposed the grid of the old Murray Valley Highway, concrete bridge abutments, and line plantings of exotic trees that survived underwater for decades. Number 25. West of Sydney, the filling of Warragamba Dam in 1958 created Lake Burragarang, flooding the Burragarang Valley to secure the city's water supply. The reservoir submerged the former mining and farming town of Natai, along with coal mines, orchards, and historic roads under up to 100 metres of water. Today, the drowned valley sits inside a restricted catchment zone managed by Water New South Wales, where entry is prohibited and the remains of the settlement lie beneath 2,000 billion litres of impounded water. Number 24. Along the Derwent estuary in Tasmania, the drowned river valley holds deep structural evidence of post-glacial sea level rise. At the end of the last glacial maximum, roughly 20,000 years ago, sea levels sat approximately 120 metres lower than today. As the ice sheets melted, rising ocean waters flooded the ancient bed of the Derwent River, turning freshwater channels into a deep tidal ria that extends 25 kilometers inland. Sub-bottom acoustic profiling conducted by marine geoscientists reveals ancient river terraces and alluvial gravel deposits buried beneath 30 meters of estuarine mud. Number 23. Off the coast of South Australia, Spencer Gulf and Gulf St Vincent represent two massive flooded rift valleys formed by tectonic extension along the Adelaide Rift Complex. Prior to the marine transgression that began 14,000 years ago, these gulfs were vast, dry, alluvial plains traversed by ancient river systems. Marine bathymetry mapped by Geoscience Australia traces drowned paleochannels across the Gulf floor, where freshwater drainage once flowed southward toward the shelf break before ocean waters breached the southern thresholds. Number 22. In Moreton Bay, Queensland, the drowned valley of the Brisbane River lies submerged beneath coastal sand sheets and marine sediment. During periods of lower sea level, the ancestral Brisbane River flowed across 30 kilometres of dry coastal plain to empty into the Pacific Ocean near North Stradbroke Island. Seismic reflection surveys reveal the original bedrock channel of the river, sitting over 30 metres below current sea level, carved during glacial periods when the coastline sat far to the east. Number 21. Across Bass Strait, the land bridge connecting Victoria and Tasmania was completely submerged around 12,000 years ago. Known as the Bassian Plain, this vast, low-lying region spanned over 60,000 square kilometres and contained a large brackish lake system fed by rivers from both landmasses. As sea levels rose at rates exceeding 1 metre per century, the ocean breached the eastern and western sills, drowning the plain and isolating Tasmania from the mainland. Number 20. Off the coast of Western Australia, the drowned Sahul Shelf once extended Australia's landmass hundreds of kilometres northwest toward Timor. Covering over 200,000 square kilometres, this shelf was dry land for tens of thousands of years, featuring freshwater lakes, river gorges, and extensive grassland habitats. Hydrographic surveys demonstrate that rising sea levels drowned 70% of this landmass between 14,000 and 9,000 years ago, submerging an entire continent-scale landscape under 40 to 100 metres of the Timor Sea. Number 19. In Spencer Gulf, South Australia, the northern mudflats around Port Augusta contain buried mangrove forests encased in coastal sediments. Radiocarbon dating of wood samples retrieved from core drills shows these mangroves flourished 7,000 years ago during the mid-Holocene sea level high stand, when regional sea levels sat up to 1.5 metres higher than present. As sea levels stabilised and dropped slightly to modern heights, the shoreline retreated, leaving the ancient intertidal zone buried beneath terrestrial wash. Number 18. In Spencer Gulf, the Fitzgerald Bay stranded shingle ridges form a series of elevated gravel beaches running parallel to the current shoreline. Deposited by storm waves during the mid-Holocene high stand 6,000 years ago, these beach ridges now sit up to 3 metres above the reach of modern high tides. Geologists use these stranded gravel barriers as physical tide gauges, proving that regional sea levels and shoreline positions have continuously shifted across the Australian continent throughout human history. But how do researchers verify if human presence left permanent traces on these drowned shelf landscapes before the ocean reclaimed them? Number 17. Off Cape Bruguiere in the Dampier Archipelago, archaeologists from Flinders University and the University of Western Australia identified Australia's first confirmed underwater Aboriginal cultural site in 2020. Using high-resolution multi-beam bathymetry, side-scan sonar, and underwater visual transects, the Deep History of Sea Country project mapped 269 stone artifacts submerged beneath 2.4 metres of seawater. Optically stimulated luminescence dating of surrounding sediments confirmed the stone tools were deposited on dry land at least 7,000 years ago, before rising post-glacial sea levels inundated the coastal plain. Number 16. In the same archipelago at Flying Foam Passage, marine archaeologists mapped a second submerged site sitting 14 metres underwater. Divers documented submerged freshwater spring outlets and stone-napping debris scattered across an ancient limestone ledge. Hydrodynamic modelling by the Australian Institute of Marine Science demonstrated that these lithic artefacts remained in situ despite centuries of tropical cyclone surges, proving that submerged terrestrial archaeological deposits can survive marine transgression without being displaced or destroyed. Number 15. Off the coast of Arnhem Land, high-resolution bathymetric surveys conducted by Geoscience Australia revealed the drowned course of the ancient Melita River system beneath the Sea of Timor. Airborne laser bathymetry and acoustic sub-bottom profiling traced a massive submerged canyon system that once drained an area larger than Victoria. The survey data mapped drowned waterfalls, ancient gorges, and terrace features 50 meters below current sea level, providing physical proof of an extensive river landscape occupied prior to 9,000 years ago. Number 14. In Spencer Gulf, marine geoscientists from the University of Adelaide used continuous seismic reflection profiling to map the drowned delta of the ancestral Broughton River. The acoustic profiles pierced 30 meters of seafloor sediment, revealing buried channel geometry, gravel bars, and deltaic lobes deposited during the late Pleistocene. This sub-bottom acoustic technique allowed researchers to recreate the precise river flow paths that existed when Spencer Gulf was an arid valley floor 12,000 years ago. Number 13. Off the southern coast of South Australia, multi-beam sonar imaging identified the drowned coastline of the Eyre Peninsula, sitting 120 meters below the surface. Marine geomorphologists mapped distinct wave-cut limestone cliffs, drowned sea caves, and ancient beach dunes along the continental shelf edge. Radiocarbon analysis of marine shell fossils embedded in these submerged terraces confirmed they were carved by wave action 20,000 years ago during the peak of the last glacial maximum. Number 12. In the Geographic Bay region of Western Australia, airborne laser bathymetry captured precise three-dimensional elevation models of the seabed through 15 meters of clear coastal water. The laser system shot 10,000 light pulses per second, penetrating the surface to map submerged granite reefs, drowned shorelines, and paleo-drainage channels, mapped previously only as featureless nautical charts. This optical technique revealed subtle structural topography that traditional acoustic single-beam echo sounders routinely passed directly over. Number 11. In the Joseph Bonaparte Gulf off the Northern Territory, geochemical core sampling conducted aboard marine research vessels retrieved preserved plant macrofossils and freshwater mud from 40 meters below the sea floor. Carbon-14 isotopic dating established that these terrestrial sediments were laid down 11,000 years ago in a vast freshwater wetland system known as Lake Carpentaria. What standard navigation charts showed as open marine water was proven to be a drowned lacustrine basin. But what are the ongoing consequences when these drowned landscapes shift from scientific discoveries to active modern hazards? Number 10. In Bass Strait, the presence of drowned river channels and paleodunes complicates offshore infrastructure development. When energy companies surveyed seabed routes for the BassLink electricity interconnector and offshore wind developments off Gippsland, high-resolution bathymetry revealed deep sub-bottom channels filled with unconsolidated post-glacial sediments. Engine teams had to recalculate trenching depths and cable-laying routes to avoid unstable marine muds resting inside ancient riverbeds that sat above water 12,000 years ago. Number 9. Off the Pilbara coast, the discovery of submerged cultural landscapes at Cape Brugiere directly transformed offshore industrial assessment protocols. Under the Western Australian Aboriginal Heritage Act 1972, marine infrastructure projects, including port expansions and subsea gas pipelines, now require marine hydrographic and underwater archaeological surveys before disturbing the seabed. What was once treated as routine dredging of empty seafloor now requires detailed side-scan sonar evaluation to ensure submerged lithic deposits and ancient occupation sites. The Australian government has committed over $80 million to construct marine seawalls and bunds to protect these communities from tidal inundation, demonstrating how the ongoing post-glacial marine transgression continues to threaten human habitation on the shelf edge. Number 6. Off the coast of Adelaide, the drowned delta systems of Gulf St Vincent affect modern groundwater discharge patterns. Hydrogeological studies conducted by CSIRO confirmed that freshwater aquifers originating on the Mount Lofty ranges extend beneath the Gulf floor along ancient buried river channels. Submarine groundwater discharge carries urban and agricultural runoff directly into the marine environment through these subsea paleo channels, bypassing coastal monitoring stations and altering marine nutrient levels kilometers offshore. Number 5. Along the New South Wales coast, drowned river valleys like Port Jackson and Broken Bay dictate modern urban planning and transport infrastructure. Sydney Harbour is a drowned river valley carved during periods of low sea level and flooded 6,000 years ago. Because the bedrock floor of the valley lies up to 60 metres beneath water and mud, major infrastructure projects like the Sydney Harbour Tunnel and Western Harbour Tunnel required specialised immersed tube and board tunnelling techniques anchored deep into Hawkesbury sandstone beneath the drowned valley floor. Number 4. Across the Great Barrier Reef Lagoon, bathymetric mapping by James Cook University identified more than 100 drowned paleo river channels breaching the outer reef wall. During glacial low stands, these channels carried massive sediment loads directly into the deep Coral Sea. Today, during extreme flood events, rivers like the Burdekin discharge sediment and agricultural runoff that flows along these same submerged pathways, carrying pollutants directly out to the outer shelf reefs along paths established over 100,000 years ago. But what happens when the most critical drowned sites sit directly in the path of modern industrial expansion? Number 3. In the Dampier Archipelago, marine surveys conducted off Murujuga identified underwater rock art panels and stone arrangements submerged beneath 6 meters of water. Traditional owners have maintained oral histories describing coastal landforms and islands that were connected to the mainland prior to the post-glacial sea level rise. High-resolution multi-beam sonar verified that submerged limestone platforms match the precise geographic contours preserved in these indigenous oral accounts for over 7,000 years. Number 2. Across Bass Strait, marine geoscientists mapped a drowned central basin containing the submerged remains of the ancient Bassian River. Airborne laser bathymetry traced a continuous submerged river system that once collected drainage from northern Tasmania and southern Victoria, flowing west to discharge into the Southern Ocean near King Island. Seismic profiling confirmed this 60,000 square kilometre valley sat dry and supported human movement until rising oceans severed the land bridge roughly 12,000 years ago. Number 1. On the Murujuga coastline off northwestern Australia, marine archaeologists confirmed 2 underwater archaeological sites at Cape Bruguières and Flying Foam Passage, recovering over 300 stone tools from the seabed. Using optically stimulated luminescence dating and hydrodynamic sediment modelling, researchers proved that these stone artifacts were manufactured and deposited on dry land before the ocean flooded the continental shelf. This finding established that millions of square kilometres of Australia's submerged continental margin contain intact, preserved evidence of ancient human occupation. What kept these submerged landscapes unnoticed for so long was a fundamental blind spot in survey practice. MAPS treats the high water mark as the edge of human history, simply because cartographic authority ended where the tide came in. Only a tiny fraction of Australia's 2.5 million square kilometres of continental shelf has been mapped using high-resolution acoustic or laser bathymetry. Hundreds of thousands of square kilometres remain recorded only through low-resolution satellite altimetry or sparse lead-line soundings taken decades ago. Marine archaeologists and geoscientists are racing to map these submerged landscapes before industrial dredging, subsea pipelaying, and offshore energy infrastructure permanently disturb the seabed floor. The official map sheet looks complete, but the actual ground beneath the tide remains largely unread. Which coastal landscape or submerged feature in your state or territory has always seemed unexplained to you? Tell us in the comments below, and subscribe to follow along as we map the continent place by place.